The volcanic eruptions are spectacular events, and people are aware of the risks caused by explosions. Lava flows, and fragments of molten rocks fired into the sky, are attractive for people. Gas seepage through the soils is a silent process that exposes people at risk in volcanic islands. Suffocation can occur because of a high concentration of carbon dioxide in these emissions. We are designing an early warning system for gas hazard mitigation at Vulcano, based on identification of the volcanic degassing surfaces, and monitoring of the soil CO2 flux. Since the end of the last eruption, the fumaroles at the crater rim and the soil degassing in the settled zone of Volcano, carried the volcanic gases into the atmosphere. Modeling of the carbon isotopic data and gas flux enabled estimating the volcanic CO2 in the soils, and to identify the anomalous degassing zones of Palazzi and Faraglione, which lies in the settled zone of the island. Anomalous degassing occurs from almost 11% of Vulcano, but these zones emitted half of the volcanic CO2 released by soils. Thanks to a new technology designed and developed at INGV, we aim to mitigate the gas hazard at Faraglione. The early warning system bases on 4 new stations to upgrade the current monitoring network. Each station measures the soil CO2 flux, the air CO2, and the weather parameters on the hourly basis. Routine software on board allows data broadcasting, and database updating at the observatory. Scheduled data processing occurs by using the plotnet, that is a C code designed in our laboratories. A suitable early warning includes knowledge of both the causes and the main effects of the volcanic degassing. Training the resident people on soil degassing help achieving long-term positive results for gas hazard mitigation. The continuous monitoring of soil degassing enables implementing sophisticated short-term alert system, for aware using of the risk zones.